By scrutinizing the Hubble Ultra Deep field, the deepest image of the sky ever made, the NASA ESA Hubble Space Telescope and the NASA Spitzer Space Telescope have joined forces to discover 9 of the smallest, faintest, most compact galaxies ever observed in the distant universe.
This is the Hubblecast, news and images from the NASA ESA Hubble Space Telescope. Travelling through time and space with our host, Dr. J, aka Dr. Joe Liska.
Hello and welcome to the Hubblecast. One of the most fundamental questions that we all ask, astronomers and laypersons alike, is where do we come from? Now we, the Earth, the Sun and the rest of the solar system are all part of the Milky Way galaxy, and so the question of our origin is closely linked to the birth and evolution of galaxies. Now, the Spitzer and Hubble Space Telescopes have joined forces to discover 9 of the faintest, youngest and most compact galaxies ever observed in the distant universe.
Conventional theories of galaxy evolution predict that small galaxies in the early universe evolve into the massive galaxies of today by merging together. The newly found young galaxies offer important new insights into the universe's formative period, just 1 billion years after the Big Bang. Hubble has detected sapphire blue stars residing within the 9 pristine galaxies.
Although they are glowing with the light of millions of stars, each of the newly discovered galaxies is actually 100 to 1,000 times fainter than our own Milky Way. Now, usually, smaller things in space tend to be less interesting to astronomers than the larger ones, but in this case it's the opposite. 3 of the new galaxies appear to be slightly disrupted. Instead of being shaped like rounded blobs, they appear to be stretched into tadpole-like shapes. Now this is a sign that they may be interacting and merging with neighboring galaxies to form larger, cohesive structures, just as predicted by theory.
The galaxies were observed in the Hubble Ultra Deep field with Hubble's Advanced Camera for Surveys and the Near-Infrared and Multi-Object Spectrometer, as well as Spitzer's Infrared Array Camera and the European Southern Observatory's Infrared Spectrometer and Array Camera.
In today's Hubblecast, we have a special guest, Dr. Martin Kümmel from the European Hubble Group in Munich. Welcome, Martin.
Hello, Dr. J.
Now, you and your colleagues are responsible for the particular instrument mode on Hubble that was used by the scientists. Can you tell us a little bit about that?
The so-called GRISM mode in the Advanced Camera for Surveys spreads the different colors emitted by the galaxies into short trails. This is an example of such a GRISM. One can see the rainbow colors as the light is spread out.
So how was that used by the scientists?
Well, the analysis of these short trails allows the detection of emission from glowing hydrogen gas, giving the distance as well as an estimate of the rate at which stars are formed.
But could that not be done in a different way?
Finding and analyzing these small and faint galaxies at such great distances is at the very limit of the capabilities of the most powerful telescopes. The GRISMs on board Hubble are the only instruments that can make this kind of discovery.
By finding these 9 tiny and exceedingly faint galaxy building blocks, we followed another branch of our galactic family tree and moved a small but important step closer to understanding our cosmic roots. We already know about the existence of much more massive and therefore considerably brighter galaxies at similarly great distances. How these monsters were assembled so quickly after the Big Bang remains a real puzzle for astronomers. But that's a story for another day.
With these small galaxy building blocks, we are basically witnessing galaxy formation in action. Something that is important if we want to understand our origin on a cosmic scale. This is Dr. J, signing off for the Hubblecast. Once again, nature has surprised us beyond our wildest imagination.